Hey, yo, hey, yo. Today we're going to start talking about 4.2C, modeling chemical reactions and notes. This is the paper that you need right here. It says 4.2C. Thanksgiving's right around the corner, so let's do a joke about a turkey. What do you call a turkey running through the streets? Fast food. All righty, you got it. Here we go. Today we're going to look at how we can use models to describe the changes in matter that occur during a chemical reaction. You can use word form, we can use element symbol form from our periodic table of elements, and we can also use pictures. So let's get going. You don't need to write anything yet. This is just review. Process. Steps taken to complete a task. For example, making bread and brushing teeth. Let's go ahead and get in there. There we go. There's a process to making bread. You have to take items out, you have to mix them together, you need to put them in a warm place, let them rise. It's a process. Substance, which you've heard many times before, is matter with the same properties throughout. For example, when you test vinegar, no matter whether you test the left, the right, the top, the bottom of it, it's always going to come out as vinegar. Baking soda is another example of a substance. You don't need to write this either. You've been working with the definition of chemical reaction, a process in which atoms of one or more substances rearrange to form one or more new substances with new properties, whether it's new colors, new density, just a brand new structure. All right, now we're going to start writing. So you're going to start writing right up here in this section where it says change in properties. And here we go. Get back here. All right. Change in properties of substances is related to the rearrangement of atoms in the reactants and products. So please make sure you're pausing through to write these down. There are three things that happen during a chemical reaction. The bonds on the molecular level break apart. They separate and rearrange, and then new bonds are formed to produce new substances. The basic structure of a chemical equation, you'll write this down where it says reactant plus reactant, an arrow, product plus product. And what it's really telling you is that whatever you're mixing is going to be on the left of the equation, and whatever comes out is going to be on the right of the equation. So we're going to continue to write where it says basic structure of an equation. And we're going to be right here in this section as we're starting to write about reactants right now. This is where you just wrote right here. So let's get back to it. All right, so the first thing is a reactant is what you start with. And it's written on the left of the arrow. I'll show you an example in just a moment. The product is what is produced by the reaction, whether it's a new colored substance, it's going to be a different state of matter, what are produced by the reaction, but these are written on the right. Here's an example of a chemical equation for your next box down. Water plus carbon dioxide, and this is in word form. And then you have that arrow, which gets you sugar and oxygen. And this is exactly what a plant does. A plant's going to take in water from the ground. It's going to take in carbon dioxide from us. It's going to take in energy from the sun. And its chemical equation is going to make itself sugar. That's its own food. That's why many vegetables and fruits taste sweet. And it's also going to make our oxygen. So thank goodness for plants and their chemical equations. We've talked about symbols before. They are one or two letters that represent an element. First letter is always capitalized. The second is always lowercase. And here are two examples. C is the symbol for carbon, and Ag is the symbol for silver. I know you've seen this multiple times already yesterday, but a chemical formula is a combination of symbols that represents the elements in a molecule. It's just another way to write the information. This is going to be brand new for you, and this is you are going to write. The subscript is the number placed below the element symbol and to the right in a chemical formula that tells the number of that type of atom in the molecule. And so you can see there are 2 oxygen atoms here, which make it a molecule. There's 2 nitrogen atoms, which make it a molecule. 2 more oxygens. Here's 4 hydrogens, and here's 2 hydrogens. So this is called the subscript, the tiny little number. Kind of looks like an exponent in math. All right. Modeling and writing chemical equations. So we're going to make water, as water was made a long time ago. All righty, let's get this back up. Here we go. And so you can write the chemical equation in 3 ways. And you're going to write this one starting with word form. And then you can write it in chemical formulas with just the letters. And you can also make visual models. So here's what water looks like and how it was created billions of years ago. So the first thing we have is to write it in words. And what you'll write on your paper is under word form. You're going to write the word oxygen. You're going to write the word hydrogen again. And on the right side of the arrow, the product is water. These are all words. You can use chemical formulas, which means you can use the chemical symbol for oxygen, hydrogen, and H2O. That's the chemical formula for water. And the third, you can use visual models. Reactant of hydrogen, reactant of hydrogen, reactant of oxygen, and they combine to form water. For those of you, most of you, if you want, you can quit out right now. Everything I'm doing from here on is aspire to do for my future chemists. So once again, you can cut bait right here. You just have to make sure that you finished all the way down to here. If you finished all of this, you're good. You can leave this right now. This is just going to be for a group that wants to go a little bit deeper in. And so let's go deeper in. All right. So in this one, we're going to take magnesium atom. We're going to react it with 2 hydrochloric acid and molecules to produce 1 magnesium chloride molecule and 1 hydrogen gas. So go ahead and pause this and take a moment and try to write this in word form on your paper. Write it in the chemical formula and write it in the visual model. Go ahead and pause now and then unpause, and then you can get the answers and see if you're correct. So I'm going to pause it now. All right. Welcome back. Here's your word form. Maybe you got that right. Here's your symbol form. Pause as you need, make any changes. And here's your visual model. Make any changes that you need. And here's what it looks like. Here's your word form. Here's your chemical symbol form. And here's your model form. Well, good luck, my future chemists. If you gave that a try, we're done for the day. Talk to you guys later.